This is day two uh, for demo session. We are talking about course artificial intelligence for professionals. I mean, this is a course designed to make you proficient for AI-related career jobs. This is hosted. You can get more details on the site skilledcareer.in. So, in today's agenda, we are going to discuss about introduction to computer and its architecture and the operating systems. These might seem to be very simple concepts to begin with, but they have a significance in anyone's understanding for the reason that most of the calculations happen over these computers. So we need to have a we are just going through our very fundamental level of understanding before we get advanced. So yeah. So, so yeah, this is the course that I'm talking about. The course is effectively starting on 31st of January. You can see there are previous recordings and previous demo videos are also available in this site, skilledcareer.in. Just go through and get visibility in there. Now, yeah, this is designed for courses of package 20 lakhs and above for starting from beginners to 5+ to 7+ years of experience. Yeah, this course spans over 4 months. Now, what is a computer? I think this is one question that we have been getting a lot in our school days and in our college days as well. But nobody thought us in a way that might sound interesting or fun to understand. So, but yeah, taking that aside, just a second. How to Okay, so there is this unit. This is a unit which takes in some inputs through a human in the form of input devices, and then it executes the instructions that were given, and outcome will be displayed in the form of output devices. So whenever it executes any instructions, it will take some memory from its memory component, and it does the calculations. With an example, input devices could be your keyboard, touch screen, or any joystick, mouse, or whatever that is, where you are going to feed in some inputs. And once you give it, it's going to be like, hey, whenever you type on a keyboard, like add two numbers, 2 plus 3. So this central processing unit is going to understand what's the value of 2, what's the value of 3, and what they need to do it. And then the moment it does a calculation, it's going to give that as an output in any of its output devices. It could be a printer. You're able to hear me? I hope I'm audible. So
Yes, yes, you are audible.
yeah, it could be a printer, it could be a desktop, it could be anywhere. With a complex with bit of advanced analogy, it could be like, hey, you want to send in a message, you are typing in into your touch screen. Yeah, and I'm sorry, it was just a yeah, anyways. So this is a simple typical example of how a computer works. Now, you might ask, like, how does a computer know what to do? Under the hood, what exactly is happening? Because it's not a human. It cannot understand English. It cannot understand any complex language. It's just an electronic device. So you might think, like, why? How things happen under the hood? That's when the logic of the bits comes into the picture. So to give a simple example, the most fundamental uh, way of computer working is more of in on and off signal. So this is called a bit. What is on and off signal? It's just as simple as a switch. For example, there is a switch. If you supply power to it, it becomes on. If you cut off power to it, it becomes off. That's the simple analogy on which a computer works. And whenever you say something like, hey, store a value of 1. So what computer is doing, or the way computers have been built is more of like whenever you type one, that one gets translated into a series of these on and off configurations. So that's called ASCII characters, ASCII characters. So each character has got one ASCII signature. You can just as an action item take an action item called go through and look for ASCII characters of various things. So I don't know about the acronym of what it holds, but yeah, each component. For example, when you type A has got a specific ASCII character which translates into a series of on and off signals. So whenever you type it gets stored into a particular component, a memory component in a computer. So now, uh, coming back to this initial picture, like whenever you type like A and for example America. So whenever you type it, so each character gets translated into a specific uh, series of on and off switches. A M E R I C A. So in this way, each character holds in is going to be stored on any memory device. So it could be your hard disk, it could be uh, RAM or whatever that is. But it's just going to be stored in the form of memory bits, and then it's going to be executed as per the instructions. So now, yeah, I mean, I explained this concept already earlier, the atom of information, like how. So now within this, uh, making your computer, let's just give me a second. Yeah. So making your computer do this series of operations is what we are going to get a lot of activity done through them. Now, even your emojis are being stored to a particular ASCII character. So, for example, if you type like "Hi smiley" ASCII character, you could see that even this character has got a signature. And whenever you send this kind of emoji to any of your conversational channels, it's going to get translated through that series of this thing, and then it's going to get communicated across various network. Now, so then you might ask like, hey, how are images represented? I'm okay with characters, I'm okay with letters, I'm okay with some emojis getting some signature. What about the photos? Like how are they being stored? So you might know there are primarily three colors which make the whole color spectrum, that is RGB. So whenever you come across some color called yellow, so yellow is basically a combination of these two, these two, some combination of red, green, and blue. So it will change accordingly, and then it will just get stored. So consider that you have an image called blue image. So whenever you store a photo of consisting of primarily blue image, so under the hood, this blue image is going to get a series of bits, and that's how you're going. And these instructions will be understood by the central processing unit, and then it's going to be represented over a monitor. So the way the CPU understands, it's just going to be in the form of bits, and it's going to translate or give the output instructions such that the monitor displays a blue color. So you might ask, like, these are very silly concepts. So why am I being taught? But these make the fundamentals of your AI engineering. For example, in AI engineering, it's all about the numbers. Since how you calculate and come to an outcome. Yesterday, we discussed about the most predictable outcome through some machine learning model, right? So it all happens through this kind of series of calculation. So we are just going through and brushing our knowledge on the way a computer understands human instructions, and how it interprets and how it displays it in the form of outcome. So now, uh, These series of information, like I mentioned about on-off switches, they're very hard to remember, or they're very hard to pronounce. Very hard to. They're illogical to be explained over any programming concepts. For that reason, uh, these computer manufacturers, they have adopted a concept of hexadecimal. Hexadecimal is just that 0 1 2 3 4 till 10, and 9, and A B C D E F. So these everything can be represent is going to be represented in the form of hexadecimal. It's just for memory addressal. It's not like computers will store all these characters now. It's just that to have a easier understanding in memory allocation, computer memory manufacturers have adopted this kind of a hexadecimal methodology. But under the hood, everything memory storing happens over binary, that is zeros and ones. Now, you might say, like, hey, you are saying binaries and zeros and ones, but generally images are being represented in the form of bytes, megabytes, kilobytes, or gigabytes, terabytes, petabytes. So what's the relationship between them? So now, yeah. So I mean, since bits are very smaller and very insignificant, so they have been grouped in the form of 8 bits. So here you could see there are 8 bits: 1 2 3 4 5 6 7 8. So these 8 bits form one byte. So similarly, 1024 bytes. You can go through some the calculations of gigabytes, uh, megabytes, kilobytes, and etc. So generally, the conventional way of allocating a memory is being done through bytes, and that is being stored so that logically your CPU addresses accesses the information in the form of this byte. So that's where the bytes concept comes in. Now, just a second. Yeah. So getting back to this. So whenever you type something, it's going to be stored. Earlier I mentioned that things are going to be stored in the form of memory. So memory is just a plot of empty array of information. So for example, a simple analogy could be uh, your city. So each city has got a perfect block. So consider that this is your memory card. So in this memory card, whenever you dump in some information, the CPU allocates memory to this particular section of elements. So this is called memory allocation. That happens on the uh, memory card, or hard disk, or whatever that is. So uh, to this is how memory gets stored, and how gets retrieved from the processor. Now you might ask, like, hey, how does a CPU know where to store? It doesn't know, right? It's just some what you call array of some very big area. It's going to be like thousands and thousands of memory grids. How will it understand where to find the address? So that's when the concept of pointer comes in. So pointer is like what you call an address to a location. So it's more of like, uh, consider that there is who some consider that there is a person called Ram. He's being housed at this address, and tomorrow he might get changed. And your CPU, if he comes and searches for a person's name called Ram's home, he will not be able to find it. So generally, what computers do, or what CPU does, is it will go through the particular address. So this memory has got a pointer address. So this address is going to be in the form of hexadecimal, which I already explained earlier. And then whenever it wants to carry out any operation, it just executes it through the pointer. It's going to be like, hey, go to what do you call Mumbai, Church Street on First Shop, instead of like, hey, go to Taj Hotel. He will. I mean, CPU doesn't do that. CPU is more of like tries to stick to the pointers, and allocates the memory, changes the memory, alters the memory, or deletes the memory. So that's how things happen under the hood on the memory level. Okay, so I hope I was able to explain what happens in here. Now, you might ask, like, you are saying, hey, computer understand things on a very binary level, and whereas I won't interact with it on a binary level. Like, I am not typing zeros and ones, zeros and ones. Like, how does that? How, whenever I type something, how does that translate into binaries, and then whatever that you are saying under the hood? So it happens through these three layers. That is, a computer has like so there is this CPU, and then there is this input device. So within that CPU, there is going to be operating system. I mean, like, sorry. So whenever you are going to interact with the CPU, it's not going to be, you are not directly going to access it at a core level. You are not going to instruct like, hey, go into that address and store something. It's going to be done through different languages. So basically, it's as simple as the machine understands only machine language, which we discussed so far. Whereas in and this giving instructions to in ones and zeros is not a feasible solution. Then there is a compiler which takes that accountability of converting your assembly language. So here you could see like sorry, whenever you type something, I'm sorry, I will just take back some of my inputs. So whenever you interact with some input device, what happens is, for example, you type like, hey, store some input into memory, store some variable to a number. So whenever you do this, what happens under the hood is it translates it translates this kind of an instruction into a assembly language. Assembly language is something very it used to, I mean, once these computers were manufactured in the earlier days of operating systems, people didn't have any of these high level languages. It's going to be they wanted to interact with these machines, but they didn't know how it was too cumbersome to write ones and zeros. So that's when they invented this assembly language. It was more of like, hey, take some memory input, delete it, add it to another memory input, change it. So this is how assembly language looks like. Move some value into AL register, add something. We don't need to know all these kind of things. It's just that how things work under the hood is what I'm trying to explain in this session. So after this assembly language, then people realize, no, this is something. I mean, if you ask me, even Apollo 71. I think so. Apollo, which was launched to reach moon, most of its programming was done in this assembly language. So then people realize this is not a way of writing programs. We cannot write with this kind of complexities of understanding how to store the memory, from move it from one place to another place, how to do something. Then they realize, no, the high level languages come into the picture. From the year 90s to till today, there have been lots and lots of languages. For example, Python, C, Java, Rust. C++, C hash. So these are just high level languages, and each language has got its own pros and cons. If you ask me, C is more of very fast. It's very native to assembly language, and it ensures that any program runs on a very quick and very fast. So whereas the weakness of the C is more of like it's not memory conscious. In our earlier discussion, we discussed about array of in memory. There are specific addresses and memories, right? C doesn't care about those kind of things. It just dumps the data and then it just fetches the data. The programmer has to think about where he is storing the data and how he is accessing it. It's cumbersome. So then came like bit of advanced languages called Python, Java, where they ensure that the user doesn't need to worry about all those kind of things. That's when that memory safe word comes in. So these languages takes care of the memory. So whenever you type something like, hey, take give me a calculator, so which adds to number. So whenever you given an input like 2 plus 3 is equal to 5, the program should automatically remove the variables which are not needed by the end of the program. For example, once this calculation is done, you don't need to store the value of plus, you don't need to store the value of 2, you don't need to store the value of 3, right? So the program takes care of this kind of removal of addresses from the memory automatically once a program is done. So that is called memory safe languages. So they are a bit slower in operations, but they take care of the memory allocation and stuff. So this is how it's going to look like whenever you interact with the computer. Now, okay, fine. I got to know how to talk with the computer. Like, who is exactly working under the hood? You might ask, like, what exactly is happening? Whenever I type something, things are happening. Who is doing that? So that's when this operating system comes to the picture. Operating system, think of him as more of like a manager who takes your instructions and what you call delegates accordingly. So, for example, there are 5 programs, and you want to run all 5 programs once, but if the CPU doesn't have the capability, it will just crash. So, this operating system comes in as a mediator. He understands which are the most essential ones, which should be prioritized, what should be done with them, when to what you call execute them, when to close them. So all those kind of activities are going to be done by operating system. So how it does is going to be in the same way through stack and memory. It's more of like storing the memory. It's just an orchestrator who gets your instructions done. So now you might be questioning yourself, what is this? I'm not looking at things in action. I'm just getting theory. I'm not understanding anything. So I mean, you don't need to think on those lines, for the reason that you're not going to deal with this on a day-to-day basis. You are going to use this tool to I mean, you're just going to use this knowledge to work on something bigger. So it's more of like in yesterday's example, we wanted to establish a path between Bangalore to Mumbai, and we wanted to lay out a transportation method. It could be airways, it could be transport, it could be flight, bike, or whatever that is. But before we establish all these kind of transportation methods, we should know how to talk, how to walk, how to see things, how to observe things. This is just that. You're not going to walk from Bangalore to Mumbai with this kind of knowledge. It's just that your fundamentals are being sorted through this basic level of information. So now, coming to the operating systems, what exactly happens? I mean, to summarize what we discussed so far, whenever you give instructions, I mean, the CPU or a chipset, it's CPU within which there are multiple chipsets. They understand only ones and zeros, that is called bits. And the memory addressal for these bits happens over bytes. I mean, that's how the interpretation happens. And whenever you want to interact with a memory, it's going to be done through operating systems. So operating systems takes care of all these kind of hurdles, which has through you. So now, once this kind of since under the hood everything happens through binary, uh, yeah, so everything happens over binary. Now you have got some orchestrator who gets things done for you. Now these operating systems, there are various operating systems. It could be uh, Windows, it could be Linux, Fedora, Debian, Ubuntu, Red Hat. So who are they? What are they exactly? They are just different flavors of this orchestrator. Some orchestrators, for example, Linux. So Linux is free and open source. So now I don't know what is open source. Open source is something like people who are enthusiastic in nature. They came up like there is one person called Linus Torvalds. So what he did is I mean, so this operating systems was very proprietary knowledge earlier. Only big companies called IBM used to have it. Windows used to have it. So they were not what to call available freely for anyone to use. it's more of like you need to pay them to use their software. Even today, you are paying for Windows license. Pirated versions is a different thing, but logically speaking, you are still paying for today their operating systems. So what they are giving you is just a thing that you can execute in your CPU, a thing which you can install it. You don't know what is under the hood, how it is being written, how to change it, how to tweak it, and you don't know it. So those kind of softwares called those are Windows. They are more of like a proprietary operating systems or closed operating systems. You don't get to tweak them, you don't get to open them, you don't get to execute them. Whereas once this kind of what you call monopoly was there, a very closed kind of very uh, yeah, I mean, monopoly was there. Then this person, Linus Torvalds, he used a particular operating system called Unix. He built it or he used it. I don't recall, but yeah, he built operating system called Unix, which is free and open source. What is free and open source is more of like you can see under the hood how this operating system is written, how it executes some instructions that we discussed as a part of this class earlier, how you can tweak them, how you can change them for your customizations. And in today's world, close to 85 to 90% of operating systems, even including any of the websites, Android for that matter, they're all running on these open source operating systems. There are different variations. It could be Kali, it could be OpenBSD, FreeBSD. These are all various flavors. So each thing excels in a different what do you call angle. For example, Ubuntu, it has two variations. One is headless and head. So you can use it in your desktop. You can use it. You can deploy it into a computer with no desktop. Uh, Anything. Let's not get into the details of what exactly are the specialities of operating system, because you're not going to need it. It's just that think these Windows and I don't recall which is the other one. Yeah, Windows and Apple, for that matter, they are all proprietary operating systems. For that matter, Apple operating system is built on Linux. They have took the Linux, they have which was freely available, and they have made in some customizations such that it works proficiently on their MacBooks or iPad operating systems and etc. So yeah, this is all overall about computers and operating systems. Any doubts?
Hello.
Yeah.
Yeah, like, can you provide job security or how? Yeah.
So, job security, yes. What we do is we take care of, uh, we ensure that you are capable of clearing the interviews on your own. We will take up mock interviews. We will take up what you call multiple resumes. We will try to polish your resume as much as possible. And after that, we are going to pass in your resume to the recruiters. So the moment recruiters are having vacancies, they have a talent pool, and they are going to shortlist your resumes for interviews. But the clearing of interview is something you are going to put efforts on. Until making you attend the interviews is our prime goal. Clearing the interviews, after the course is completed, you will be in a position to clear this interview.
Okay. Okay, thank you.
Yeah, thanks. Hi Pranav.
Hello, sir.
So yeah, I mean, I know this is day two's demo session. Yesterday's demo session wasn't covered. I think you registered on yesterday evening, right?
No, sir. I done it long back. I couldn't attend yesterday's class.
Okay, fine. Yeah, I will start. Do you have any questions for this particular session?
No, sir. What was done yesterday, sir? Like,
It was. I will just go through briefly. Just give me a second.
sir. And is this a course for like uh, job or like even like students can take it up?
Yes. This course is designed for people who want to get into careers, AI jobs. This is for both non-IT people. This is for return to work professionals. This is for people who are students who are looking for jobs. So there is a lot of demand in the AI industry, and this course makes you capable of attending those kind of AI careers. The more details, you could just visit the website. I think you might have already gone through that, right? So uh, we ensure that we by the end of these 4 months, you will be in a position to attend and clear the AI related interview career job opportunities.
Okay, sir. Yes, sir. Thank you, sir.
Yeah, thank you. So yesterday, I think what we covered was just a second. Yeah. So I mean, maybe I will try to rerun I will share the recording. It was just nothing. What exactly is an artificial intelligence? It was over brief. I explained it over brief, but maybe I will re-record it and publish it. Nothing of technicalities. It is just about how we are going to teach the program. For example, in this class, in this training course, it's going to be more of computers, how to operate with them through operating systems, programming fundamentals, how to use cloud, and AI related fundamental knowledge, and then how to deploy models, how to tune your pipelines. Whenever a company wants to have its own chat GPT within the company, how we are going to deploy it. So those kind of things we are going to cover as a part of this course. And the course is designed to be spanned over 4 months. This is for on 3 days, Saturday, Sunday, and Wednesdays. The training happens. On the rest of the days, co-working session happens where it's going to be hands-on working sessions will be done by the participants. So that's the structure of this program. Now, yeah. So the way this course is structured is going to be more of very beginner friendly. What we mean by that, yeah, as you might have already seen in as a part of this earlier class, it's going to be more of we feel that everyone will not have a same understanding with the technical systems, software industry, and etc. We assume that everyone is not having any understanding with, and then from there we are starting from the scratch, where uh, by 50 to 70% of the interview we will help you to self explore. So 0 to 30%, it's more of like very basic to very beginner friendly. I'm sorry, I'm being repetitive. I apologize for that. When I say that, you as you might have seen, I have started with computer operating system, how to program, how to store the program in the form of Git and etc. 0 to 30% of the course focuses on that, and 30 to 50% is more of like very where we you are in a position to self explore. By this point, you'll be more of like how to find new information whenever you have doubts, where to go for attaining it, where to how to get your doubts cleared, where to what exactly we will lay out a map for you to venture out and learn more. And by 70% of the interview, sorry, by 70% of the course, you will be in a position to attend the interviews on your own. I'm reiterating, even before the completion of the course, by from the 70th percent itself, you'll be in a position to attend the interviews and start uh, what you call trying to put an efforts to clear them. By 100% of the course, it's going to be more of like full-fledged. You will be completely aware of how to tackle the questions, how to give beginner introductions, self introductions, how to cross question. So those kind of things we are going to teach as a part of this course. So that's what I mean to say about adapted learning curve. It's also more of like if someone is lagging behind, everyone doesn't learn at the same pace. Some person has a higher learning curve, other person has a lower bit learning curve. If a person is having a bit slow learning curve, what we will do is we will give in additional inputs to them, like, hey, watch this video, come back to me, I will explain it to you in a much detailed manner. Again, we will have a follow-up with them. Again, we will have a follow-up with them. So uh, this kind of approach helps everyone to learn in same pace. I don't want to, if out of a group of 10, if there are 5 engineers who are learning in a very proficient manner, and if the other 5 are struggling, I don't want to hold back the people who are doing good. So instead of that, I'm going to make the people who are learning slowly, I will bring them to the speed, and we go everyone learns at the same pace. So that's how it's going to be. So one thing that we expect from people who are learning slow, it's going to be more of like they should be willing to put in more efforts. What I mean by that is daily close to 1 to 2 hours per day is far more than efficient uh, to come to what you call decent pace. Yeah, I hope I was able to answer your question.
Yes, sir.
Yeah.
Sir, and as of now, it's not a paid course, right, sir?
Yeah, till 7th of December, it's going to be a free course. Next session is on
7th of
February.
December, sir.
Yeah, February 4th. Sorry, uh, February 7th. The next Sunday. Then the next session is going to be on Wednesday. The next session is going to be on Saturday. So after this, I will see how it can be done. But till demo sessions are available, as per currently they are planned till 7th of February. After this, it's going to be a paid course. We'll see.
Okay, sir.
Okay, so how, I mean, do you have any doubts with respect to the the computer systems and operating systems, or was it clear? Do you need it in much detailed manner? Is there any inputs that you need to be you need to convey?
No, sir.
No, it's
Okay,
clear.
yeah, okay. In next session that's going to be held on yeah, in next session that is going to be held on Wednesday, that is February 2, 3, 4th.
Oh,
Yeah, on 4th of
oh,
February, we are going to talk about operating systems, Linux, how to get what you call how to get your own operating system, how to use it, how to practice on it, what are the different commands to it, and then from there we will go into Python. It's going to be, we will slowly start. Even for that matter, even though I have planned the class for 1 hour, I am taking in 30 to 40 minutes only, for the reason that I don't want to overdump with information. For that reason, I am limiting the content that I am putting in the initial stages. By the time people are warmed up, people are in a position, people are in a form, then we will increase the content. We will going down the line, I'm going to give in work assignments for them to explore, review, self explore, those kind of things we are going to increase slowly. So on Wednesday's class, it's going to be Linux, how operating system, how to install it, how to use it. After that, Python, cloud, all those kind of things we are going to cover. In the site, you can find the curriculum in a brief. The curriculum modules haven't been started yet. So these yesterday's and today's class were more of like complete scratch beginner basics. They are like day zero fundamentals. So once we are well versed with this kind of terminologies and computer ecosystems, then we will start the modules, then we will start the class. Yeah, I hope you got benefited out of this course. If you have any doubts, please do reach out over WhatsApp. You already have my WhatsApp number in the skilledcareer.in website. Please do reach out there. This recording is going to be uploaded in the site. Please do share this site over to your friends. Sign up is free for the demo sessions. Uh, if we don't see much of a participation, I'm going to extend the demo sessions period for further long. But yeah, please do share as much as possible. This is going to be a very job focused program. It's not only very theory and practicals. It's going to be targeted to attend and clear those jobs itself. Yeah, There are videos that are available. I think it would justify if I had shared those kind of videos. Go through the website. I have uploaded the demand analysis in the site. That should give a brief picture. So the demand for the job is there. You can watch this video. It is briefly explains the current demand in the industry. What you are going to learn is covered briefly as a part of this video, and payment instructions. You for 35,000 is not for everyone. Students get different package payment ratios. For example, they have for them there are some benefits available from the AI tool providers. They have a different payment structure. For students, it's going to be 27,000. For others, it's going to be 32 to 35,000. You can watch that video and you can understand that. And you can see much more details as a part of this. So module 1 starts on Wednesday, where you're going to touch base on all these kind of things. After that, we will further cover the course. I hope this session has been helpful. Any doubts, please do reach out to WhatsApp number that's been mentioned here. We'll be responding to you from there. Cool.
Yes, sir. Thank you, sir.
Thank you. Thank you.